Hey, this is Austin, and today I want to talk about command line arguments. So I have a simple file here, right? Um, and if I want to add command line arguments, I can just put int argc and char pointer argv, and pointer argv is the same exact thing as pointer argv array. So basically what this is, an array basically kind of is a collection of pointers because, for example, if I were to do int a for array, and then I don't know, 1, 4, 5. And if I were to print all those values out, I could actually print them off like this. Print a Oh, I can't increment the value, but I can get the first value from the array like this. So if I run this, I'll get 1, right? And you can run, if you don't know how to run it, you could do gcc, and then the name of the file that you want to run. It's a long name for me, but, and then you just do / to run the program, and then by default it makes a.out as the program name, the compiled program, and then you can run it like that. So 1. We already know it's the first value in our array, so I could do like 5, right? I can't increment this, but if I made a pointer to that, int pointer, a pointer, right? And I did AP. I did this like 3 times, right? Then I should get all the values of the array. I should. Or I did not. Oh, I didn't set it to A. There we go. Yeah, so I set it to the memory address of A. And now, bam. Actually, I don't need to do and A. I don't know why I did that. Let's make this a different value. Because the first element, A, already is a pointer. But, you know, that's kind of what I wanted to show you, but a little bit not off subject. But anyways, if I wanted to read from these arguments, right, I can set arguments by doing, actually I'm going to make a command right here. And just says to do this command and then to do this following command afterwards, right? So I'm going to compile the program with gcc and then the program name. Then I'm going to do and also run the program. So that's what I'm going to do, right? And right now I don't have it doing anything, but if I had to write something after this, right, then that would be the command line argument. So if I wanted to get that argument, what I could do is argv is for arg value, so I could do dereference this array of pointers, and I'm going to add a plus plus, and I'll tell you later, but this should give you the first argument, right? That's the first argument you were given, but technically the first argument that you supply is the name of the program. So really the first argument is dot slash a.out, and then the second argument is actually whatever you supplied the program, whatever argument you supply to the program. At the end of this argv array is null. So you could actually loop through all the arguments like this. Well, argv is not equal to null, then argv plus and then I'm going to dereference it. Yeah, so that gives you all the arguments, right? And I only supplied it with 2, but if I supplied it with more arguments, I could do, I don't know, hey, what up? All right, so now it prints every argument. So what's happening here? Basically, in a for loop, right, you have 3 things. You have, right here, you can define a variable in this first area, and in the second area, right here, you set a comparison to set when to stop the loop, and then you have some type of increment here. So for me, I didn't need to set any variables because the variable was already set when the program started. So all I did was dereference the argument value. So I basically dereferenced where it was pointing to in the array, and I said, if that is not null, then keep incrementing the pointer. So keep incrementing where the array is pointing at. So okay, now I'm going to point to the next array, the next string, the next string, and the next string. And then I'm going to say, okay, well, give me that string. I'm going to dereference that section of the array and get the string from that. So that's just kind of a simple way to... and if I didn't want that a/out, I could do argv plus, right? So now I don't get that /a.out, the name of the program. So that's pretty simple, right? We didn't even need to use the argument C, but argument C right here is the count of how many arguments there is. So now it should print 4, which is correct. We have this argument, this argument is 1, this argument 2, 3, and then 4. The only time I really used argc is to compare whether or not the program has enough values to run, or arguments to run. So yeah, another useful thing for command line programs is get opt. It's a very useful function. So I'm going to delete everything in here. And then what I'm going to do is I'm going to say, well, actually first I'm going to set a variable ch. Do while ch equals get opt. And we have to give it argument count, argument value, and then whatever options we want. So an option, right, in a command line program is trying to find a good example. ls, right? This will list all the files, but if I did ls, but if I made it, for example, ls-l, it'll tell me the read and write permissions. This right here, this -l, that's an option. And I could add more than one option. So I could do ls-l a, right? But yeah, so I can add multiple options here. I don't remember what -f does. What does it do? I just kind of guessed, to be honest. -f, do not sort. And then it says disables colors. So what I did right here was I said, okay, list all of the did -L for list the permissions of the file, and then F does, I think it removes the sort and disables the color. Actually didn't do the first one, that's weird. Apparently you can't add them at the same time. But I'm sure from that you can kind of conclude what options are. So I could add an option A, then while I'm getting these options, say, well, it's not equal to -1 because getOpt will return -1 when it's at the end, when it can't read any more options. And I commented ch. And what I can do is I can just print off the options that it found, just for now. Let's go back to running our program. And it didn't find any options there because there wasn't any. But if I did -A, which is the, right, it says, oh, I found an option, which is the ASCII, D is the ASCII character for that, ASCII value for that character. But if I did it like that, then bam, you see that we get A, which is really helpful. There's also a value that getOpt also gives you an argument called opt end. Yeah, opt end, like that. That's the index that it's currently on. So that's helpful. So when you have another option, right, that requires an argument after the option, then you could do, for example, if we have F and that requires an argument, then we could do, let's make a switch for our ch and do case if it's equal to F. Then what we're going to do is we're going to print off the argument for -F, the option argument. That's what. So what we're going to do is argv opt ind, and then -1, because it's once it found F, it's gonna move. It always moves to the next option, but we already know that the argument for F is gonna be 1 before the next one, so that's why I did -1. And this colon right here basically says, hey, this F, it has an option. So I'm just basically saying right there that it requires an option. So if I did -F, hey, typed whatever after, it gets the option and it prints it off. So that's an easy way to get options right there. But this is all cool and it's great, but how do we save the configured options, right? Well, one way you could do that would be really long and drawn out. You could actually use, I'm going to include std bool, and I'm going to make an array of booleans, or you can make an array of chars. They're just as big as a boolean. Bool options, right? And let's say we have 10 different options, right? And let's do, I don't know. Let's say the option A is, let's do this way. Hashtag define option A equals options 0. Now this is kind of a long drawn out way to do it, but But I think you're kind of getting the point here. So I'm just going to make 3. Let's just set this to 3. A lot easier to change. So now we have a Boolean, right? And we have 3 definitions, option A, option B, and option C, all set to different points in that Boolean array. So what we can do is, let's actually make the options A, B, and C, make this easy, right? If it's option A, then we can do option, and wait, before we do that, let's initialize all our values to 0. When we set anything to an empty block like that, it automatically initializes the array, everything in the array to 0. So that's what I'm doing there. And what I can do is go back here and say options option A equals 1. Bam. So now we oh, I put an equal sign, didn't I? Yeah, you don't do that. I didn't even realize I did that. Oh well, doesn't matter. But yeah, we can continue this trend here. Place this B, option B equals 1, and then do the same thing for C. So now we know when each option is turned on or turned off. And then we can do this. We can say for I equals 0, as long as I is less than 3, I is plus, right? Oh, and I put commas instead of semicolons. And what I can do is I can print every element of that array. So we said the array name was options. So then we could do options. So now it's going to print okay. That should print all the options that we make available. So if I put A, it should just show the first option at 1. But if I put A, B, and we could actually label these. I don't want to do that. If we put A, B, then the first 2 are going to be 1. But if we put A, B, C, all 3 of them are going to be 1. Now this isn't the most ideal way to do this because a Boolean takes up, let me do something real quick. Make this float. A Boolean takes up 4 bytes. So we can conclude that if we have 3 options, right, that means that we can determine how many bits those options, that array of options is going to take. So we can do 2 to the power of 3 minus 1. Yeah, 3 minus 1. 3 times 4 plus 1. Yeah, I think, yeah, that's got to be right. So that would be the total number. Wait 1 sec. A byte is 8 bits. So it'd actually be 1, 2, 3. Yeah. So that's how many bits these 3 options would take up. Right? See all these black highlighted bits? Right? All of this. That's all the bits all those options would take up. But there's a better way to do this, because we don't need to have that much memory taken up at once. So what we could actually do is we could set up, I know it's going to show an error. It's going to show an error at first, but int options, yep, and then copy that. And then we can say option A equals 1 shifted to the right, left by 0. And then this could be 1 shifted to the right by 1. This could be 1 shifted to the right, shifted to the left by 2. So now we have 3 different options, right? And all 3 of them are going to be like this. So we have 1 shifted to the right by 0, and then by 1, and then by 2, right? So we could actually set this up to be the size of a char, which would be 8 bits. So that's going to only take up that many bits. A lot less bits than before. And now what we're going to do instead is whenever any of these options are selected, so first we're actually going to set this to 0, just a kind of, or null, I guess could be a better way to say it. Set it to 0. I don't know why it shows some weird thing there. And then what we could do is say option equals options option A, copy that, place that B, and replace this with C. So now we have the same thing happening, right? But we have a whole lot less space, memory being consumed. And now we can do, even if we want to see if an option's on, right? We could do printf option A equals, and then this will be on or off, so 0 or 1. And we could do, let me think about this, options and option A, right? That'll, then we can copy this. This will determine if option B is on or not. And this will determine if option C is on or not. So if we rerun the last command, it should show that, ooh. Oh, I added a semicolon, didn't I? Yeah, don't do that. Yeah, this is gonna copy, yeah, when you do define and then you type the name, it's gonna be word for, like, this is basically copying this chunk right here, so 1 bit shifted by 0, and it's gonna literally copy that with whatever this is. It's an alias for that. I don't know, I added some things I shouldn't have, but yeah, you can see that they're all set. If they're greater than 0, then they're on, right? But if we did that, right, then we see that C is not set. Or if we just set A, right, we just see that A is set. If we just did B and then A, for example, then you can see that B and A are both set. So it's a much easier way to deal with options right here. There's one more thing that might be a little helpful, is that whenever there's a character that basically isn't available, right? Isn't in this list, it'll return a question mark. So case question mark, meaning it's not an available option that you have. You could do, I don't even need a break. Do exit one, meaning there was some type of, actually what I'm gonna do is break and then say bool bad option. I'm gonna set this to false. Bad option is true. And then if bad option, and it'll print off all the bad options by default. And then to use exit, we have to, well, I don't necessarily need to use exit. I can just do return, then return 0 here. So let's say I put an option that I didn't make available. So these are the available options, A, B, and C. If I put Z, right, it says invalid option Z. And that's kind of how you can handle errors a little bit. And that's all I'm going to do for now. Hope it was helpful and informative, and hope you learned a lot.